Joint variation is the next pattern that we'll talk about. This is basically direct variation, except joint variation is when a variable varies directly with two or more variables. So here, z varies directly with x and with y. If x gets bigger, so will z. If y gets bigger, so will z. So we can say that z varies jointly with x and y. So two or more. So we could also say here, p varies jointly with q, r, and s. In both of these cases, a is still just that constant of variation. X and y, q, r, and s are variables. So here we could say p varies jointly with q, r, and s. The examples that you do won't really be any different, but you'll just have to be given the values for 3 variables or 4 variables at the start of the problem in order to find out what the constant is. So our first example says that z varies jointly with x and y. Z is 60 when x is negative 4 and 5. Write the equation that relates the variables. Then find z when x is 7 and y is 2. So again, first thing we've got to do is find the constant of variation. So z varies jointly with them. So that follows the pattern where z equals a x y. We know values for x and y and z. So we plug those in to find a. Negative 4 times 5, that's a negative 20, so negative 20a is equal to 60. Divide by that negative 20, and we will get a negative 3 for a. So our equation relating z, x, and y is z equals negative 3xy. Okay, make sure to give me that equation. Don't just say a is negative 3 and then move on. Give me that equation that relates those variables. Then find z when x is 7 and y is 2. So plug in 7 for x, 2 for y, negative 3 times 7, negative 21 times 2, negative 42. For these next couple examples, the words there give us a relationship between two variables, and what I want you to do, or what we're going to do, is take that and turn it into an equation. So, for a, if y varies directly with x, that's the direct variation, so y equals ax. Let's just put in a for a constant of variation. So y equals ax would show that y varies directly with x. Y varies inversely with x. So that's b. Y varies inversely with x. That's the one we just learned about. So y equals a over x, or if you put xy, if you put xy equals a, that's fine too. That shows inverse variation with x and y. Z varies jointly with x and y. Again, that's the one that looks like z equals axy. It means it's varying directly with both of them. Okay, moving forward. D, y varies inversely with the square of x. So we know that if y varies inversely with x, it looks like y equals a over x. But if it varies inversely with the square of x, instead of just x on the bottom, we would have x squared. So y equals a over x shows inverse variation with the square of x. As the square of x gets larger, y would get smaller. Or as the square of x gets smaller, y would get larger. So last one, z varies directly with y and inversely with x. So z varies directly with y, so that's going to look like direct variation. So there, if y gets larger, so will z. But then inversely with x means that we're going to see that x being divided there. So this shows direct variation with y. If that piece gets bigger, so will z. And then the inverse variation, so x, we're dividing by x, because if x gets bigger, we want z to get smaller. Okay, so you'll have a few kind of like that on your worksheet to do as well.